Well, welcome to lesson 11, and we're going to start out with some review stuff just to make sure we have some of this stuff down before we get to the new stuff. Let's start out with the distance formula. Given the points x1, y1, x2, y2, the distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. The equation of a circle, x minus h squared plus y minus k squared equals r squared, where the point hk is the center of the circle. The slope of a line using the same points as above, y2 minus y1 over x2 minus x1. Three forms of the equation of the line. Well, we have the slope intercept form, where m is the slope and b is the y-intercept. We have the point slope form, where x1, y1 is the point and m is the slope. And we also have standard form for an equation. Midpoint formula divided by 2, same with the y values. And our new word that we're going to use is angle of inclination. So if we're going up from the horizontal, it's an angle of inclination. And if we're going down from the horizontal, this is an angle of depression, because it's going downward. And the angle of inclination is the angle is measured counterclockwise from the positive x-axis. Determine the relationship of the angle of inclination theta to other known quantities of the line. So if I have, let's say I have the line and I think I just tried to do 2x plus 1, simple enough. And I want to find the angle of inclination there. Well, we know that since we already know we're looking for that angle and our slope is 2, our run is 1, so I'm going to say the tangent of theta is equal to 2 over 1. And if I do the inverse tangent of each one, I get a theta of 63.4. So my angle of inclination of the line y equals 2x plus 1 is 63.4 degrees. I think we played with this a little bit in geometry, and if given a point x sub naught and y sub naught and the equation of line in slope intercept form, then that gives you the distance from the line to the point of anywhere. Okay, so be something to write down. I think we got one coming up here. So suppose that a line is such that the value of its x-intercept is twice the value of its y-intercept, and then it goes through the point 1, 3. Determine the equation of the line and the line angle of inclination and the distance the origin is from the line. So if my y-intercept, let's read that again, such that the x-intercept is twice. So if I'm at 2, I'm at 1. If I'm at 4, I'm at 2. those lines. But we want it to go through a point 1, 3. So it has to go through this point. So if I go up to 4, then I would be over at 8. 1, 2, 3, 4, 5, 6, 7, 8. And looks like it's not going to be a nice one where it would look like that. It's going to probably go through like 7.5 or something like that. So let's see if we can come up with that equation. The first thing that I know is that my slope, if I'm going down 1, I'm going over 2. So my slope is got to be a -1/2, whatever it is. And if it goes through the point 1, 3, that seems like that's the perfect setup to use the point slope form. So I'm going to go with y minus y1 equals m times the quantity x minus x1. And so I'm going to, oops, that's a minus, add 3. So I get y equals -1/2 x plus 7/2. So is the equation of my line. And then let's start answering some of the questions that they ask us here. It says determine the equation line. I did that. The angle of inclination. Well, my angle of inclination measured from the horizontal. So if I extend this out, my angle of inclination would be from the horizontal line all the way around to here. And it appears to me that it's actually an angle of depression because it seems like it's going downwards. So why don't I go ahead and find this from the horizontal here, my angle of inclination, since it's going down. And we know that it's going down at a rate of over 2 and down 1. So I'm going to use the inverse, or the tangent of theta is equal to the opposite over the adjacent. Inverse tangent, inverse tangent. And let me bust out my calculator here. I better pause. So it looks like my theta is a 26.6 degrees negative angle. So if I'm going to do it counterclockwise to the positive x-axis, I would have to go 360 minus that 26.6, which gives me 333.4 degree angle. So either a -26.6 or 333.4 positive. Determine the equation of that angle of inclination. The distance, the origin is from the line. All right, so the last thing that we're going to figure out, I'm going to give myself a little more room. And I'm going to use that formula that's right up here. And we want to use the general form of that equation. And if I solve, I get x plus 2y equals 7. And I'm going to also use the point 0, 0. There's my x sub naught and my y sub naught. And my a is 1, my b is 2, and my c is 7. And if I recall correctly, I'm going to plug in and I'm going to get d equals the absolute value of 1 times 0 plus 2 times 0 plus 7, all over the square root of 1 squared plus 2 squared, which gives me, looks like 7 over the square root of 5, or 7 root 5 over 5. Okay. Circles. Let's talk circles for a second. So 3 points determine a unique circle, and determine the equation of a circle that passes through those points. Identify the center and radius. All right, first thing I'm going to do is I'm going to give myself a picture of what's going on. So here's 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my negative 12, 1, and 0, 7 is something like that. Well, because these are on the same line, I have a pretty good idea what the diameter of this thing is. So we're going to, and the general form of our circle, I'm going to x squared plus y squared plus dx plus ey plus f equals 0. Well, what I'm going to do is I'm going to plug in, because we have 3 points, and we're going to plug them in, and we're going to end up with 3 equations, 3 unknowns. Well, that's the stuff that we were doing in the last section. So here we go. Let's do it with the first one. If I put it in, I'm going to get negative 12 squared plus 1 squared plus d times negative 12 plus e times 1 plus f equals 0. And so I get positive 144 plus 1 plus, or minus, 12d plus e plus f equals 0, or negative 12d plus e plus f equals negative 144. So in my matrices, I'm going to write it down here, and I'll erase it when I do the next one. My first row of my matrices is going to be negative 12, 1, 1, and negative 144. And then I'm going to do the same thing with the next point, and I'm going to get 2 squared plus 1 squared plus d times 2 plus e times 1 plus f equals 0. And if I get my equation right here, I get 2d plus e plus f equals negative 5, which would give me the row 2, 1, 1, negative 5. And do the same thing with my third point, which would give me a 0 for the x, which is kind of nice. So I'm going to go with 0 plus 7 squared plus d times 0 plus e times 7 plus f equals 0, or 7e plus f equals negative 49, which in my matrices I would have the row that looks like this. So what I'm going to do now is I'm going to pause and get these answers by doing it on a piece of scratch paper, and you can do it too. Simplify it in row echelon form and then solve. And let me do that. So I solved it, and I got that d was equal to 10, e was equal to negative 4, and f is equal to negative 21. So then I put them in, and we end up needing to complete the squares to find out what those values are. So I'm going to take b divided by 2 and squared. So 10 divided by 2 is 5. 5 squared is 25. And if I add it to one side, I need to add it to the other side. Half of negative 4 is negative 2. Negative 2 squared is 4. So I get that. And then writing it in vertex form, I get x plus 5 squared, y minus 2 squared equals 50. All right, so there's your circle of your equation, and it asks me to do 2 things, find the center and the radius. So I'm going to say my center of this thing is at the point negative 5, 2, and my radius, which is of course the square root of 50, I'm going to rewrite that as 5 root 2, because that's the square root of it. All right, so now, good. Interesting stuff. So then, let's do this one. Hold it, I don't have enough time. I'll pause here and start the next video.